Looking at automotive history, some engines are not just a technical solution, but also a vision. They work in unconventional ways, push the boundaries of engineering, and hold a special place in the hearts of car enthusiasts. The Wankel engine is exactly one such engine. So why has such a different, innovative, and theoretically advantageous engine almost completely disappeared today? Why don't we see Wankel engines in mass-produced cars anymore? In this video, I will explain the Wankel engines, history, working principle, technical specifications, which vehicles it was used in, and most importantly, why it ended. In detail but in an understandable way. Don't forget to subscribe to the channel to follow the fascinating content of the scientific world. Ready? Let's begin. The story of the Wankel engine begins in the 1950s. Its inventor is the German engineer Felix Wankel. Interestingly, Felix Wankel wasn't a mechanical engineer with a university degree in the traditional sense. However, from a young age, he had a great interest in rotary engines. He began developing his first ideas in the 1930s, but the work slowed down due to World War II and the subsequent economic conditions. The real turning point was his collaboration with NSU Motoring Work. In 1957, the first working Wankel prototype was produced. This engine was completely different from piston engines, operated with a rotating rotor, contained far fewer parts. In the 1960s, many manufacturers such as NSU, Mazda, Citroën, and Mercedes-Benz showed great interest in this engine. In fact, at that time, the Wankel engine was considered the future of internal combustion engines. The Wankel engine has a very different structure from classic piston engines. Let's examine its most basic features in bullet points. No pistons. An epitrochoidal body instead of a cylinder. A triangular rotor is used. It has a rotating mechanism. Thanks to this structure, the Wankel engine is much more compact, is lighter, can easily reach high speeds, has low vibration. It operates with a smaller volume and fewer parts compared to a piston engine of the same power. This theoretically means less mechanical loss, higher power/weight ratio, smoother operation. Before we delve into the operation of the Wankel engine, let's examine how classic piston engines work. Classic piston engines are systems that have been used in the automotive world for over a century, with their basic operating principles largely unchanged. At the heart of these engines are cylinders, pistons, connecting rods, and a crankshaft. Energy production occurs through the up and down movement of the pistons within the cylinder. Piston engines generally operate on a four-stroke principle. These four strokes are called intake, compression, combustion, and exhaust. The first stage is the intake stroke. In this stage, the piston moves from top to bottom within the cylinder. The intake valve opens, and air, or in gasoline engines, an air-fuel mixture, is drawn into the cylinder. In diesel engines, only air is drawn in. During this time, a vacuum is created in the cylinder, and fresh air is supplied. The second stage is the compression stroke. The intake valve closes, and the piston begins to move from bottom to top. The air or air-fuel mixture inside the cylinder is compressed. This compression increases combustion efficiency and allows more energy to be released at the moment of explosion. Both valves are closed during this stage. The third stage is combustion, or the power stroke. When the piston reaches top dead center, in gasoline engines the spark plug produces a spark, while in diesel engines the fuel ignites spontaneously due to the high temperature. The high pressure resulting from combustion pushes the piston downwards with great force. This is the stage where the engine actually produces its mechanical power. The downward movement of the piston rotates the crankshaft via the connecting rod. The fourth and final stage is the exhaust stroke. The gases produced after combustion are no longer useful. As the piston moves upwards again, the exhaust valve opens, and the burnt gases are expelled from the cylinder. Thus, one cycle is completed. To understand the working principle of a Wankel engine, we first need to forget about the classic engine. In this engine, a triangular rotor rotates inside a specially shaped housing. Each surface of the rotor forms a separate combustion chamber. The four basic processes that take place inside the engine are 1. Intake, 2. Compression, 3. Combustion, 4. Exhaust. However, these processes occur not linearly as in piston engines, but through rotational motion. As the rotor rotates, one surface takes in the air-fuel mixture. Another surface performs compression. Combustion takes place on the third surface. In this way, the engine produces continuous power with each rotation. This is what allows Wankel engines to rev at very high speeds, produce linear and fluid power. Which vehicles used Wankel engines? Mazda was the brand that used the Wankel engine the most and practically made it its identity. From the 1960s onwards, Mazda invested heavily in the Wankel engine. The best-known models are Mazda Cosmo Sport, 1967, Mazda RX-7, Mazda RX-8. The RX-7, in particular, became a legend in the automotive world. Thanks to its lightweight structure, high-revving engine, and excellent weight distribution, it was a favorite of performance enthusiasts. Other brands included NSU Row 80, Citroën GS Birotor, Mercedes-Benz C111 Concept. However, these brands soon abandoned the Wankel engine. Mazda, on the other hand, continued to produce this engine until 2010. So why did the Wankel engine become obsolete? Now, let's get to the most critical part. Why did the Wankel engine become obsolete? There are numerous critical reasons why this engine is no longer used. Let's explain them point by point. 1. Fuel consumption problem. One of the biggest disadvantages of Wankel engines is their high fuel consumption. The shape of the combustion chamber makes homogeneous combustion difficult, increases heat losses, reduces efficiency. Especially in city driving, Wankel engines consume significantly more fuel compared to piston engines. 2. Emission and environmental standards. One of the most decisive factors in the modern automotive world is emissions. Wankel engines produce high HC, unburned hydrocarbon, emissions. Exhaust gas control is difficult. Put strain on catalytic converters. Strict environmental standards, such as Euro 5 and Euro 6, have almost completely closed the door on Wankel engines. 3. Apex seal problem. The weakest point of the Wankel engine is the sealing elements called apex seals. These parts are located at the ends of the rotor, ensure the seal of the combustion chamber. However, are exposed to excessive heat, experience lubrication problems, have high wear rates. This shortens engine life and increases maintenance costs. 4. Oil consumption. Wankel engines, by their nature, burn oil. This is part of the design. However, this situation is environmentally negative, worsens user experience, increases emission values. This is not acceptable in the modern automotive world. 5. The rise of electric vehicles. In recent years, the automotive industry has undergone a major transformation. Electric and hybrid vehicles are rapidly replacing internal combustion engines. Companies do not want to invest in new engine technologies, avoid risky and niche solutions, turn to more efficient and regulated systems. This has accelerated the end of specialized engines, like the Wankel engine. Is the Wankel engine completely over? Actually, no. Mazda plans to reuse the Wankel engine as a range extender in the context of a constant speed generator. In this scenario, the Wankel engine does not directly power the wheels, only works to generate electricity. This minimizes its weaknesses while highlighting its advantage of compactness. Conclusion: the Wankel engine was revolutionary from an engineering perspective, was the product of a bold idea, was far ahead of its time. However, fuel consumption, emission problems, durability problems made it incompatible with the modern world. Today, the Wankel engine is remembered not as a failure, but as a timeless engineering marvel. If you like these kinds of engineering stories, don't forget to like the video, subscribe to the channel, and share your thoughts in the comments. Do you think the Wankel engine could return with today's technology? See you in the next video.